Hello, everyone. Thank you for joining us this month for electrical safety discussions. I am Chris Schneck. I am our EMEA sales manager, along with our business development manager at Grace Technologies. With me, I'm joined today by Nick Augustine, who is a part of our business development team. And today, we're specifically going to be talking about advancing electrical safety. This is going to be a webinar that focuses on workplace safety, our permanent electrical safety devices, our PESDs for short, and also our GraceSense condition and predictive-based monitoring solutions. Throughout the webinar, Nick and I are actually going to cover a few different things just to highlight the different topics that we're going to be discussing here this morning. We will be focusing on the fact that electrical safety is paramount in any workplace, and adherence to regulations such as NFPA 70E and OSHA standards are not only a legal requirement, but also help enhance and assist worker safety. On top of that, we're also going to be discussing implementing best practices and utilizing advanced technologies. And by utilizing advanced technologies, employers can enhance electrical safety, mitigate risks associated with Lockout, Tagout, or LOTO, and increase safety and productivity. On top of that, we're also going to explore the importance of compliance, the risks involved with those as well, best practices by ensuring a safer working environment, and the return on investment, or ROI, by utilizing innovative permanent electrical safety devices such as our PESDs, specifically our voltage indicators, our check volt product, and also our safe test point devices. So thank you again for joining us. I think we're going to kind of segue right in. We're going to dive right in here. So Nick, I want to kind of segue over to you here. Let's start by focusing on the importance of compliance from not only NFPA 70E, but also OSHA, just a standard compliance from those regards.
Well, the general reason that we're following these standards that are set, and this isn't just one company or one person coming up with any of these standards, an NFPA or OSHA. It's a group. It's a collaborative effort of a lot of professionals across a wide array of different industries that are coming together to share best practices and come up with a way where everyone can follow standardized procedures to make sure that they're performing their tasks safely across any environment, and that they're going home alive the same way they came into work.
Absolutely.
At the end of the day. So a lot of that is going to involve making sure that you're doing the procedures the same way over and over again. We're going to go into a little bit of the documentation that's required for that and how we can make that safer, what OSHA recommends, how to avoid a few citations that get involved with that. And then the addition of various things like permanent electrical safety devices, PESDs, and how that can affect your lockout tagout procedure. Specifically on that documentation and the testing side, we see a lot of citations where people aren't having their procedure documented or following it routinely. And we're going to go over the instances of what's altered when you install a new device into that procedure and what that really means for the safety and productivity of your maintenance staff.
Absolutely, yeah. And so, like you were touching on, it sounds like you're hitting a couple of key points. One that I feel like at Grace, we put a lot of focus on, which is the hierarchy of risk controls, right? Mm-hmm. So that is something that we will reference throughout this webinar here today. But ultimately, the biggest added benefit of looking at the hierarchy of risk controls are where our products specifically fall in regard to those different processes and that hierarchy of risk control. So what I have found previously and just conversations with customers and ultimately folks that are actually performing that maintenance and doing that work on their particular pieces of equipment is that they're very quick to just suit up and don PPE. They're physically going inside of that enclosure. They're exposing themselves to a lot of inherent risk, right? Mm-hmm. And so not only are they exposing themselves to that risk, but there's a lot of time commitment involved with that, right? So, obviously it's not just a quick and easy, oh, I'm in my spacesuit. There's some labor that's involved with that. Obviously, you want to make sure that the PPE that you are wearing is rated and approved for that particular piece of equipment. But again, there's a lot of inherent risk with donning that PPE and exposing yourself to that incident energy. So with the addition of our permanent electrical safety devices, whether that be voltage indicators for presence of voltage verification, any of our voltage portals, our safe test point, our check volt device, even our voltage test station, these devices are designed to engineer around that risk or substitute or eliminate the risk altogether. And that kind of ties back to, I believe, some of the documentation, the standard processes and policies that folks need to look at when implementing our permanent electrical safety
absolutely.
devices.
As the industry advances, new tools become available. The PPE was a very obvious need from a very early beginning in electrical work.
Absolutely.
So the ability to protect yourself from those explosions because they were happening. But what people aren't aware of is some of the new things that come out and some of the various ways that you can achieve the same goal. Like you said, by engineering around that risk instead of just wearing a blast suit to protect you from that risk. So we'll go over a few of the standards here. I think we're going to jump right into a few of the citations that we see and some ways to work around that and stay in better compliance with OSHA and NFPA 70E and all that.
Appreciate it.
So,
yeah, absolutely. I'll take that one and I'll dive right in here. So we do have some statistics here. And again, feel free to ask questions. We are going to incorporate some of those questions throughout this webinar. We will have some dedicated time at the end as well to try to answer as many of your questions as we possibly can. But feel free to reach back out to us if we're not able to hit your question. Nick and I will be available following the webinar as well.
Yeah. So, and the ones that came in, we did ask you guys if you had any questions when you registered. We do have those. So we will address what you guys sent during registration throughout the webinar today. And we had some good questions come in. So excited to kind of address those. And if it spurs any other questions on top of it, we're going to try to sprinkle those throughout so that you guys have time to process that and ask some follow-up questions. Because like we said, if we're closing up Electrical Safety Month, and this is for you guys. So if there's anything we can help with, feel free to ask.
Appreciate it. So just a couple of quick statistics before I dive into kind of the OSHA top cited violations here. So 70% of all injuries occur during reactive maintenance. On top of that, 35% occur due to direct contact with wiring, transformers, or other electrical components. 60% occur on three-phase low voltage systems. Now, again, I don't know about your experience. From mine, I work with a lot of customers that utilize single or three-phase applications that can range from as little as 24 volts all the way up to 480. Up in Canada, I've done some work with folks that deal with 575, 600 volts. Ultimately, a lot of our products are going to be UL listed up to 1,000 volts and intertwined with some of that lower voltage as well, that 480, 208, 220. So diving right in, knowing that obviously there's a lot of risk involved when interacting with live voltage. In 2022, OSHA revealed that the control of hazardous energy standard was the 6th most violated citation, receiving a total of about 2,200 different violations or citations. That was an increase of 505 more than in 2021. So looking at those different citations and the different categories, the first main heavily cited violation is the energy control procedure. And so obviously this is going to look at procedures that need to be developed, documented, and utilized for control of potentially hazardous energy when employees are engaged with activities covered ultimately by the hazardous energy that they're working with, right? So this is going to be the lockout, tagout. This is going to be presence and absence of voltage testing. Like Nick was mentioning, right? We want to make sure that there are documented standard procedures. Again, in the industry, we are experiencing skilled labor shortages, right? So there's usually a lot of time commitment getting people back up and running and trained to ensure that they know when they're working on that particular piece of equipment, that they're not only following the standard procedures, but they truly know whether or not that piece of equipment is energized or de-energized.
Absolutely. So one of the things that we're wanting to talk about today is that introduction of PESDs into that lockout tagout procedure. So we're selling a lot of these into facilities that have an established lockout tagout procedure. Not everyone we talk to does. So there's some of you that may be watching today that we've asked this question on webinars. Sometimes 30 or more % of you say that there's not an established electrical safety program. There's not an established lockout tagout procedure, or if there is, we don't really follow it. So one of the things that happens is as you update the tools that you're using for your lockout tagout, you're not going back and updating that procedure. You're not going back and training people. So if you get a new device and your lockout tagout procedure says that you're going about it in these specific steps, that either needs to be updated or you need to continue following those steps. So can you give an example of an existing lockout tagout procedure where if we involve the check volt, what that looks like? Because from my conversations, it's been beneficial to where you can still use your portable test meter as outlined in your existing procedures. So there's minimal input that you have to change to your existing procedures. Just a little bit of update on the testing, the qualification, and the documentation side.
Yeah, you ask a great question, and I'm glad that we'll be able to get that answered here. So the whole idea is with our permanent electrical safety devices, we're not necessarily changing the lockout tagout procedure like you mentioned. We're in essence adding these externally mounted devices and wiring them in parallel to the source voltage. So again, it's acting as an extension of that source voltage, right? So with the implementation of the check volt, for example, this is a great solution that has built-in dual redundant LEDs along with contact high impedance test points. The whole idea here is you can quickly walk up to our device, get a quick and easy visual indication for the presence of voltage. The device will come standard with dual redundant LEDs, 2 per each phase and 2 on the ground. So again, if there were any requirements for troubleshooting, or say you lose power on a particular phase, you have voltage running to the ground, or say you installed this on the load side of a disconnect. You flip your disconnect switch trying to isolate the power. However, the indicator is still illuminating on a particular phase. That would be indicative of a stuck blade scenario, right? So as you mentioned, updating the documentation and procedure. So instead of suiting up in high cal PPE, opening up the enclosure, you can keep your enclosure door closed, walk up with a portable test instrument, and perform a dead live test. Now, we do make a modification to that as well. We actually call it the dead live test. This takes it just a slight step further. So when you have your portable test instrument, we want you to test it to a known voltage source, just to ensure that the voltmeter is calibrated and working as it should.
Absolutely.
And then test that meter live at the check volt or the contact test point device that we offer, and test it live. Test it phase to phase to ground, and ensure that you're getting an accurate voltage reading. Flip your disconnect or isolator switch, test it dead at the device, phase to ground, and then again, test your meter back at that known voltage source to ensure, again, that your meter is working it's calibrated and working as intended. So again, we're not necessarily changing that process. We're allowing the user to keep their equipment door closed and reducing that overall incident energy exposure. That's really what it's all about. Elimination, substitution, and engineering around that risk.
Yeah, and that brought in a few questions. The way we install that, we're bringing the wires to the source power, bringing that to the panel front so that you can test there. And then a lot of questions came in on how are we confident that that is touch safe? Is there not still a shock risk? If you're going to 1,000 volts and you're testing there with no fuses in between, and how can we make sure that you can go up and touch that?
That's a great question. So the device, as I mentioned before, will be UL listed. On top of that, it's also going to carry an IP2X rating because of the built-in current limiting resistors. So on our standard safe test point device, that is 102 kilo ohms. On the check volt, it's 164. That is how we're able to get that IP2X finger and touch safe rating. Now, with that built-in impedance, it's actually limiting the current to milliamps. So that exposure, and in accordance to OSHA, document 3075, page number 7, any shock hazard under 6 milliamps is considered a slight shock. So bearing that in mind, there is no, risk or bodily harm that could potentially be caused because it's limiting. Yeah, there's no injury risk there as well.
All right.
That.
All right. And then one of the other on that topic was determining the equipment needed to perform a lockout tagout safely or to perform absence of voltage. So one of the ways is that if you have the arc flash rate and the calorie rating on your equipment, you can determine what level of PPE is required for that. Is there another way to go about doing that if you don't have that utility short circuit data, or what are the options that customers have? That was one of the questions that came in.
Yeah, so that's a great question. So we did do a little bit of homework, so I just want to answer that question here. Let's see. Is there another reliable method for calculating the incident energy without the utility short circuit data? That is a great question. So yes, there is another method. It's called the simplified method that can be used to calculate the incident energy without relying on the utility short circuit data. The simplified method utilizes available equipment and system data, such as available fault current, system voltage, and protective device characteristics to estimate incident energy levels. While it may not provide the same level of accuracy as the detailed method, using the utility short circuit data, the simplified method can still be a reliable approach for estimating incident energy and determining appropriate PPE, or personal protective equipment, requirements. I just also want to reiterate that it's also important to note that the simplified method should not be used in accordance with the guidelines and limitations specified within NFPA 70E and other relevant standards and regulations. So obviously, consulting with a qualified electrical professional would be recommended for accurate and appropriate incident energy calculations.
Yeah, but always we want you to work within your facility's regulations, be aware of the procedures. That's what's going to make you safe. If you need to determine the risk factor another way, that is a way to do it, because you don't want to be accessing this stuff and putting yourself into that risk, because the injuries resulting in this are potentially deadly. There's a chance you don't go home. There's a chance you live in a hospital for the next 6 days. Your company goes through all these litigations. There's so much paperwork and insurance, and it's a headache for everyone when all we need to do is engineer around that risk and find a safer way to go about it, especially with the labor shortage, especially finding the qualified electrical workers that are able to do this and be more productive throughout their day.
Yep.
So with all those injuries happening during reactive maintenance, while people are rushing around trying to get your facility back up, there's a lot more outcome than just losing a maintenance electrician. If he hurts himself, there's a mountain of work that comes with that, more than just losing a valuable resource for your company for, if nothing else, just a day.
Yeah, and that kind of ties back as well. We offer solutions that are easily implementable, right? Mm-hmm. We want you to be able to include these types of solutions that are scalable and easily designed to be added to your standard procedures as it relates to electrical safety. So by implementing permanent electrical safety devices, you can help with that standardization of the documentation and ensure that if something were to occur, that you are taking the necessary precautions to obviously save your workers' lives and provide them the best alternative to interacting with live voltage.
Yeah, one of the other added benefits that people don't often see too, because safety is a lot of a common sense side for our customers. And then what they're excited about is the productivity, the efficiency that they didn't see behind it. And it helps kind of make that sale point of this seems obvious, but here's what's going to help the bean counters make that decision and purchase it, is that the efficiency. And in some applications, we've been able to eliminate multiple people from the lockout tagout procedure, thereby not only speeding up the entire procedure for that one location, but enabling the other employee that was tied up there to go about being productive on their own. So my favorite example of that is in Virginia. We have a wastewater facility that on their pump stations, whenever they had a power outage that affected multiple stations, they had to respond with a technician and an electrician coordinated to each pump station. And it took each one of them about 5 minutes of work, but they had to align their schedules and meet there. So it was taking some time to coordinate that at each facility. And with the inclusion of our electrical safety devices, the flashing indicator and the safe test point, being able to verify when voltage is present, determine when it's absent, and test for absence of voltage safely, Virginia was able to eliminate requiring the electrician to show up for that task. and the pump station technician was able to arrive on his own, safely go through the lockout tagout procedure and return that facility operational on his own. So the labor, the time required for that, it's a huge output on that, and it's less dangerous to go about doing it that way.
Yeah, I think a nice statistic to add to this point, on average, our customers have seen a 74% reduction in time spent locking and tagging out their equipment. And the example that Nick used, which is a great example, we were able to completely eliminate the manpower or work of one other person. So what would take, 2 people 20 minutes took one person 5 minutes. So obviously that ties back into the productivity of the devices, obviously including them into their standard operating procedure. It sounds like that was a pretty easy example for them to start to include in their electrical safety program and make sure that they had a clear and defined process when interacting with live voltage. So this kind of ties back into some of the OSHA discussions that we were having, just to kind of close the loop on the whole OSHA top citations. So wrapping up on the energy control procedures, obviously there's a lot that goes into that: policies, procedures, documentation. There were about 640 violations alone on that specific code. Taking a step back, training and communication, which I feel like we've kind of touched on quite a bit. So when looking at adding these types of devices, updates will be required to the documentation and the policies and procedures, right? So this is a slight deviation from a standard, donning of PPE, opening up your enclosure and testing. With the implementation of our devices, it keeps that enclosure door closed. It assists with that policy and that process. So obviously updating that from a training perspective and ensuring that everyone is following that same procedure. OSHA has cited for training and communication 434 different violations. And that's, again, that all ties back to the training, having clear documented processes and procedures, and ensuring that you are taking care of your workers and having their best interest in mind. So the last couple here, periodic inspections. So this kind of ties back obviously with equipment health and ensuring that you're clearly, having some type of regular cadence. I think at a minimum, it's once per year, a PDM of that nature or general maintenance of equipment. That can vary. I've had multiple conversations with customers that do something on a biannual basis, maybe even a quarterly basis. You can never be too careful when you're inspecting your equipment. OSHA cited 338 different violations that relate to that periodic inspection piece. So again, ensuring, that this is one piece of a kind of a larger puzzle here, right? This is kind of a whole culture shift, and ensuring that, from a company level, you're getting buy-in at the top all the way down to the workers that are actually performing that maintenance.
So, in addition to, is that your completion of your list of those citations?
One last thing,
more.
Energy control program, 199 different violations. So that's ultimately establishing a program that consists of energy control procedures, employee training, and periodic inspections. Ultimately, it kind of ties all of the different variations of OSHA's requirements into one. So about 200 different violations within that as well.
So why aren't we seeing people put the focus on this where it's required? If OSHA's calling it out like that, we can go over the ROI. You have an interesting stat from OSHA that they determined, but we normally put out that the return on investment for our PESDs, say the check bolt, is payback within 5 to 7 lockout tagouts.
I actually think it's 2 to 3 now.
Yeah, we've been getting feedback. Every time we say that to a customer, they buy it and they're like, nope, we're getting that back a lot sooner. And in the right situations, it makes an incredible impact. But, and again, with all the litigations and everything else that comes with the injury, OSHA has this level that they determined your ROI for every dollar spent on safety and wellness. And what was that? It's like
so every dollar invested in safety and health, on average, you can expect to see about a $4 to $6 return. So quite a large difference in terms of investment versus return. And ultimately, I think everyone's journey is different when it comes to electrical safety. Like you said, we do talk with folks that have an established electrical safety program. sometimes that program isn't even in place. Or maybe it's in place, but it lives in somebody's head. We see a lot of tribal knowledge, and obviously with an aging workforce, workers are becoming younger and younger, and the risk associated with that, it's ultimately due to inexperience, right? So obviously making that investment, just $1 invested in health and safety, ultimately you'll see potentially $4 to $6 of a return.
Yeah, that's a pretty good return.
It is.
You've got to make an investment.
And so not only that, but you're reducing that tribal knowledge, that information that may be living in the electrician's head because he's done it for 20 or 30 years. You're able to make those investments and help the workforce, that new workforce that is now coming into the industry as well.
Yeah, you need to create a legacy of safe, effective work in your maintenance department.
Absolutely. And so again, everyone's journey is a little bit different, right? So I think that kind of ties back into where they want to start making that investment, and ultimately what that journey looks like.
Yeah. Is there any other questions that have been coming in that we want to address in regards to the return of that? Or I know we've been getting a lot of requests to go into details on our predictive maintenance system, the GraceSense side of things. So we did want to figure out a way to incorporate that into our electrical safety month discussion, because again, we do these webinars for you guys, the customers that are watching. So I guess what's next on our docket?
Yeah. So one great way to kind of segue into the GraceSense family of products is ultimately to throw out some statistics, right? So the cost of unplanned downtime in process industries is estimated to be around $20 billion with a B. That's 20 billion.
That's significant.
On top of that, 70% of injuries occur during reactive maintenance, right? So a piece of equipment randomly goes down. You don't know why. You might be cutting corners to get it back up and running. It's impacting production. Ultimately, people want to start producing, right? They want to produce their material and make money for the company, right? So ultimately, that's where corners are cut and injuries occur. So insurance companies have estimated that approximately 25% of all electrical failures are attributed to faulty or loose electrical connections, resulting in temperature anomalies, hotspots that lead to overheating, intermittent open circuits, and electrical arcs. So that really kind of ties into the GraceSense condition and predictive-based family of products. And Nick actually brought up a great Bernie and Les here. They're our mascots, right? So they help visualize our products for the Grace team. And so the GraceSense predictive maintenance and condition-based monitoring systems consist of a few different products. Our hotspot monitor and also our IIoT, Industrial Internet of Things, predictive maintenance solution. So Nick, do you want to quickly give a quick overview of the hotspot monitor, what it is, how it works, and ultimately kind of the value prop that we are trying to paint for the hotspot monitor?
Yeah. So the hotspot monitor is our way of detecting these anomalies in your switchgear or your power distribution equipment. So we've seen a lot in the medium voltage industry, our area, and but it's able to monitor locations inside your switchgear and that are not easily seen either through your thermography, and it gives you a lot clearer picture, a lot more consistent picture, especially if 1/4 of all of your electrical failures are happening because of hotspots that aren't detected. That's insane. That's an extremely high number. And then everything after that is reactive maintenance. And it's all extremely hazardous. You're not sure what the issue is. So being able to identify as equipment is deteriorating, as those connections are becoming looser, and schedule that in, that's where you're going to see a lot of that elimination. And when you start to realize that you can plan this, you can schedule it into your routine downtime, that's where you'll start to see a lot more than that $4 to $6 for each dollar. Because if you're avoiding potential downtime, unplanned downtime, you're not only resolving production issues, you're resolving shipping issues, any sales, any retail. There's a lot of steps in that chain that all require or rely on this to stay running. Because if you don't have power, you don't have motion. If you don't have motion, you don't have anything happening inside your facility.
Yeah. And I think this also kind of ties in nicely, not only from like an end user perspective, but also at an OEM commissioning level, right? Whether that be leveraging our GracePort panel interface connectors, our permanent electrical safety devices. I think you have a statistic at a commissioning level stage. Obviously, there's going to be a lot of power monitoring, flipping the equipment on and off, testing. And I think we expect to see about 8 to 10 different kind of power functioning at a commissioning level, right?
Yeah, as you're getting equipment set up, you have to, anyone commissioning, and I've been having a lot of conversations recently specifically with contractors that are going about construction and commissioning equipment on site. So as it shows up, and they get a lot of payback out of all of these. A lot of those companies do offer continuous maintenance on the facility. So like on a high-rise hotel, on a hospital, they're continuing to go in routinely and upkeep the equipment.
Sure.
A lot of those they're just called to though. If you're just the electrical contractor in the area and you say you got a hotel that calls you up saying, hey, we're having some power quality issues, we need you to come out. I'm hearing stories about opening up power distribution equipment. There's 2 inches of dust inside.
Oh.
No one's looked at it for years. There's 800 amp breakers that are just exploding out of panels. And when that happens, if something happens with your power distribution equipment, one situation had a hotel. It went down there were 2 days it took them.
Oh.
The breaker they had to repair or replace.
Hopefully no one got injured.
No one did get injured. A room
Good.
exploded, but they had to replace a part that should have been, I think it was like $16,000, ended up being $45 because you needed it yesterday. And then you have to put everyone in that hotel into a different facility and pay for that. And it ended up being $750,000 on that incident from just not having maintenance.
Yep.
So with a very low comparatively initiation cost,
$750,000.
you can monitor that remotely. You don't have to open that up and pose any risk. You can just open up the maintenance hub and see, hey, our connections are. Or you can ignore it completely and just wait for it to alert you if it identifies any anomalies.
Sure.
So that's a lot better than waiting 3 years, opening it and being like, man, we shouldn't be in here. That's terrifying.
And I think that also kind of ties back to the bigger picture, right? So this is one piece to the puzzle, but ultimately this needs to be a culture shift from a top-down approach at a company level. And so with the integration of these devices, the idea is we want you to own this process. Not only that, but we want you to be able to accurately understand and know how your equipment is performing and its equipment health. And talks with customers that leverage this solution, ultimately it definitely varies across the industry. I've seen folks contract this out. They have a third party come on site, walk around with IR thermography cameras. They only take a kind of a single snapshot in time. That could be done on a monthly, a quarterly, biannually, annually basis. And so ultimately, you're really only getting that single snapshot in time, right?
And it's expensive.
It's expensive. Not only, it's a third-party contractor that you're hiring out, right?
For very little info overall.
And ultimately that info can vary, right?
Mm-hmm.
Whether or not the equipment is running under full load or full duress. There might be viewing angle error or viewing, discrepancies where you may not be able to get a clear snapshot inside of your equipment.
It could be machinery passing by that changes what happens as your equipment's sitting there vibrating a little bit.
Exactly. And so ultimately with the hotspot monitor, it's continuous, it's fiber optic, it's non-conductive. Ultimately, what Nick mentioned as well, this device can also be seamlessly integrated over Ethernet and Modbus protocol. So that alarm, that alert, ultimately let this device do the work for you. Let it understand and trend out and baseline your equipment health and help you to identify that anomalous behavior to prevent, a thermal avalanche or an explosion, like you said, at the high-rise hotel. It sounds like a room exploded.
Yeah.
Thankfully, there were no electrical injuries during that, but, a little bit of proactive investment, obviously understanding and trending out your equipment health with the hotspot monitor can really help you understand your equipment health and give you a clear baseline of that.
Yeah, absolutely.
And so I think that also kind of ties in nicely as well to the larger GraceSense Predictive Maintenance family of products. So I know that there's a couple of different options. One is a remote vibration and temperature monitoring piece. The other is a hardwired third-party sensor integration as well. Do you want to touch on a couple of those pieces for the GraceSense side of things?
Yep. Well, the standard piece that you're referring to is our vibration and temperature node. And that we have a couple models of, depending on the frequency of the detail that you need. But what that's going to do is it's going to monitor the surface temperature and the vibrations from any of your rotating assets. So vibrations are where you're going to first see signs of an issue. Before you're able to physically see any movement, before you're able to feel any temperature or notice anything with your human capabilities, these are going to be able to identify changes in that vibration and start to alert you. And we need to stop reacting to our equipment failing. We need to stop reacting to a breaker exploding out or a bearing failing. And we need to plan when we're going to go in and do maintenance on a bearing. So if you have a vibration node that can sit there, permanently monitor, kick on every few hours, and give you up-to-date information on the status of your equipment and the health of the bearing or any of the gearbox or anything that you're monitoring, you're going to be able to schedule that out, find out whether it's going to fail, what percentage in the next 6 months, in the next 3 months, how urgent does this need to be, and we can plan this out. And again, that's going to eliminate a lot of injuries as you're not experiencing that 70% of injuries happening during reactive maintenance.
Absolutely. And obviously preventing unplanned downtime as well, right? That $20 billion in process industry for unplanned downtime. Obviously, if we can not only look at your equipment health and help you understand how it is performing, but if we can also prevent those unplanned downtime incidences from occurring, we can keep your production up and running and ensure that you're obviously remaining profitable and shipping out product in a timely manner.
All right. And I think we have a poll that we can pull up to go over if you're interested in it. We've been getting a lot of feedback to focus a little bit more on this. So in the coming months, we will have our CTO will be coming on here to go in and do a deep dive. He's a vibration genius, but he'll go over a lot of the features and benefits of the GraceSense products. And then we'll have a few more engineers in here sharing some applications, some ideas, some run-throughs. So if you do have questions, especially from anything we bring up, feel free to pull that in.
Yeah, just to add as well, the poll questions, I think there's going to be a couple of questions. So we did spend a little bit of time talking about our permanent electrical safety devices, our PESDs. I think that there will be a poll question about requesting a sample of a check volt. And then also the second poll question will be specifically geared toward the GraceSense family of products. If you're interested in learning more about the hardware, starter kits, that is something that we also can assist with as well following the webinar. But just to round out and kind of wrap up on the IoT side of things as well. So a couple of different ways of integrating this solution. You mentioned a cloud-based deployment. So that is one option.
I get a lot of feedback that people aren't comfortable with the cloud yet, though. There's a lot of confusion over the security aspects of all that.
And obviously, we want to be as flexible as possible when working with you and your specific application requirements. So the cloud is just one piece to that puzzle that allows us to get you that access to that data. We also have something called an on-premises deployment. Now, again, a lot of that deployment is done over Ethernet. On top of that, I believe we're one of the only providers, our manufacturers, that developed an AOP with Studio 5000 and Rockwell. So, obviously Allen Bradley, Rockwell, Studio 5000, that allows for a very seamless integration of our hardware and data into your existing your SCADA system. So ultimately, like you said, if there is that pushback on leveraging a cloud-based offering, you can combine any of these options as well, or you can kind of select one or the other. It makes it pretty easy for integration.
Yeah, and bringing data in is what it's all about. Chris had mentioned the panel mount node, and what we're able to do with those is bring in third-party sensors. So if you have a current transducer or you need to keep like an RTD that's already built into your system and that data is valuable to you, we can bring that in through our panel mount node, and that way you can correlate that data with the other data that you're receiving, identify patterns, and use that to your advantage. So you're not isolated to just the sensors that we're able to produce and provide. If you have existing equipment, we're able to bring that in and make it a holistic solution for you instead of just requiring you purchase every piece from us. It's not the most effective way, and it's not the way to make everyone safer.
That's a great point. I 100% agree. I mean, that's ultimately, like I said, we pride ourselves on being very easy to do business with. Our kind of our motto, making maintenance safer, smarter, and more productive. And again, we do that in a multitude of different ways through our different brands, the GracePort panel interface connectors, our permanent electrical safety devices, and now into the GraceSense condition and predictive base monitoring systems as well.
All right. And I think we have a few more questions that rolled in. So what do we have down here?
Okay. Let's see. So
some of you guys, I think, were trying to trick us by sending us real interesting questions.
First and foremost, I guess I'd like to ask, were there any questions that popped up during our webinar?
No one has submitted a question yet. Let me check I'm running the polls right now. And guys, feel free to enter into the chat and respond to those polls. And at this time, if you'd like to submit any questions regarding the webinar, we will go ahead and answer that right now. Otherwise, we're going to get to some of those questions that you guys submitted when you registered. There's a question right off the top of just in general about the webinar. Will a copy of the presentation data be available? We don't have a PowerPoint or anything, so we do record these. We send out an on-demand link afterwards to everyone who attends. So look for that later this week. But go ahead and if you guys think of any questions, go ahead and submit those in the chat now. And we're going to go through some of those previously submitted questions now.
Okay, so I have one here. What devices exist for electrical safety? So ultimately, there's going to be several different devices that you can leverage in your industrial application or environment that range from personal protective equipment or PPE, portable test instruments, multimeters, voltmeters, and then obviously electrical safety devices that act as ultimately an extension of that source voltage. So our permanent electrical safety devices, our PESDs, will range from voltage indication to help and assist with varying degrees of troubleshooting, phase loss, stuck blade, power running to the ground, generally used as a means for mechanical lockout tagout. On top of that, we also have voltage portals that consist of non-contact and also contact testing. So the contact testing side, I want to spend just a little bit of time here. So that will be our safe test point device. That will be our check volt. That would be our voltage test station. These are all going to be permanently mounted devices that are installed using a 30 millimeter push button knockout. So a small little circular hole punch. They will come with 4 wire leads that will range from 14 gauge to 18 gauge. And the whole idea is that those will be wired in parallel to your source voltage, giving you a safer alternative, keeping your enclosure door closed, keeping that harsh environment from getting inside of your panel, reducing kind of the time spent locking and tagging out your equipment, and providing you a return on your investment in just 2 to 3 lockout tagout procedures. All the while enhancing your compliance to electrical safety standards, specifically NFPA 70E. I don't know if we kind of explicitly called that out. So with the addition of these types of devices, while also being used in conjunction with a portable test instrument, you will safely be able to test and verify both presence and absence of voltage without ever having to physically go inside of your enclosure and test at the voltage source.
Yeah, absolutely. And then there was some questions around whether intelligent electric devices are classified as PESDs and or what technically makes something a PESD. So the response we had to that was that Grace has made these permanent electrical safety devices, has branded them PESDs as engineered ways to permanently install and avoid an electrical risk. So when people are asking like circuit breakers, surge arresters, smart relays, are those PESDs? And those, I believe, we're classifying as IED, intelligent electronic devices. Can you elaborate any on the difference there, or is is there any need to, or
Yeah.
do you get that question a lot? Do people ask you what all falls under PESD? Because it sounds similar to what we just.
Sure. Yeah. Again, I just want to reiterate that these are just acting simply as an extension of the source voltage, right? That is the whole idea. So bringing that source voltage to our device, having that built-in current limiting resistors. So obviously being a UL listed device, IP2X touch and finger safe rated, it's ultimately looking at eliminating, substituting, and engineering around that risk, tying that back into the risk control hierarchy. Obviously, we want to provide you a safer alternative that keeps your workers safe. So again, they're not necessarily smart devices per se. There's like no output relay or anything in our permanent electrical safety devices. Whereas, obviously that I think that would be a distinguishing factor from that, unless you have something else to add as well. I don't know what we.
No, I think that was it. Just that there's inherent safety things, but
Absolutely.
What Grace is classifying is these permanently installed devices.
Absolutely.
So
Yep.
it's where our focus is. It's we're trying to really nail down the best impact that we can have, and prioritizing with the permanent electrical devices that we have. That's what we've determined makes the biggest impact, and that's how we get such positive reviews on our PESDs and make that big impact on lockout tagouts, because we're focused on that and not trying to just cover as many product lines as possible and call them all PESDs.
Yep. Absolutely. Let's see. I see a couple other questions here. How do you use lockout tagout with safety PLCs and STO drives? So when using lockout tagout or LOTO with safety PLCs, programmable logic controllers, and STO drives, the following steps can be taken. Identify the specific safety PLC and STO drives that need to be locked out and tagged. Follow the manufacturer's instructions and guidelines for LOTO procedures specific to the safety PLC and STO drives. These instructions may include, designing and implementing protective measures in electrical systems to ensure proper and safety protection. So ultimately, I think that kind of ties back to having a standard policy and procedure in place, ensuring that you're not cutting any corners, and having the proper documentation in place as well.
And it's always advisable to refer to the manufacturer's recommendations
Absolutely.
on any equipment you're using, especially if you're going through and you're going to trust your life to a safety PLC. Ideally, they're supposed to be tested and meant for that, but various manufacturers change various things about them. So referring back to the manufacturer's recommendations would be great.
Yep. Sorry, it looks like we got a couple questions coming in here if you want to pull those up.
All right, let's see what we have.
Do you have any safety arc flash PESDs for overhead lines going to a manufacturer? A transformer. Got it. So that's a tough question. And this has actually come up in a multitude of different applications. The power lines, obviously the power coming off the incoming utility, that is generally a higher voltage than what we see with our low voltage permanent electrical safety devices. We have looked at trying to leverage our medium voltage indicator. However, that's generally used in switchgear, as it's a direct half-inch bolt connection directly into the gear itself. I haven't had a real successful way to include some of those permanent electrical safety devices. Just, again, once you get outside of the facility, it makes it a little more tricky. But if you would like to send us a quick email on that, just the specific application, maybe the environment that it'll be exposed to, I would love to learn more and see if there's something that we could figure out for you.
Yeah, if you weren't at the Offshore Technology Conference recently in Houston, that question came up a lot. There is a need for that. You're not alone in looking for a solution for that. There was a lot of interesting conversations about how to take our presence in the medium voltage world and adjust it to line up with the hazards that are present in those kind of situations. A lot of what we're focusing on, though, again, the majority of the accidents that are reported are happening with that low voltage equipment. And I don't know if it's just because people are a little more cautious when it's the high voltage on those lines,
Sure.
and then they get inside and they're thinking, oh, it's 480, 600 volts. Like,
Yeah,
know,
it's not as high voltage as working on a power utility, right? Or a transformer that's outside that's bringing that voltage in.
Yeah.
So yeah, I mean, I think that there's definitely a level of experience and comfortability, and that's ultimately where we see, obviously performing that contact test could potentially create an incident, right? An arc incident. So that's ultimately where we tailor a lot of our permanent electrical safety devices. Like you said, will be more geared toward that lower voltage application. So generally 1,000 volts and less. 480 is very common, and then we also see some single phase applications as well.
Okay, and we had one of you guys asked about Article 350 in NFPA 70E, which brought up a pretty fun conversation that Chris and I had last week while we were going over these. But the specific question was, what does Article 350 exactly cover for company-owned training centers and also for remote training areas where PESDs may be used in these areas? So what we discussed on that, first of all, so you don't have to pull out your copy of the NFPA book, Article 350 specifically covers the requirements and guidelines for electrical safety in company-owned training centers. So it addresses the necessary precautions such as proper equipment installation, maintenance, labeling, and ensuring that it's a safe working environment. So a lot of the citations that we were talking about, the same thing, the documentation, the labeling, the proving that you're doing it correctly, those are still going to be required there. Regarding remote training in areas, NFPA doesn't have a specific article dedicated to them. However, like we said, we generally want to apply these guidelines to those situations, including like your risk assessments, electrical safety programs, to make sure that you're operating in the safest way possible.
Sure.
And then the use of PESDs there, it's the same that we were talking about. So it's going to be potentially a slight adjustment to your lockout tagout procedure, but that is what Chris and myself are here for, along with many other people in our company, that if you're unsure about the change of adding one of our devices or any other device into your electrical safety program, then feel free to reach out and ask. We are happy to consult. We're happy to make sure that you and your team are performing things safely throughout the day. So if there's any confusion, you need to eliminate that. And we're happy to help. Even if we don't have it right away, we can always dig in. We have a big connection of very intelligent, highly trained professionals, IEEE senior members, senior advisors in multiple countries.
Yep.
So familiarity in a lot of different industries is how we're able to provide that feedback and then keep on top of the use cases where we want and make the biggest impact to the industry. So I appreciate that question. I hadn't read much of Article 350 myself, so that was a good learning opportunity for me.
Okay, so I think there might be a couple more quick questions.
Hey, we had some on motors and VFDs. So do motors running on VFDs, vice contactors, starters contribute to available fault current? So what those are going to do, VFDs, they don't contribute to the available fault current. They will potentially create some noise and have some impact, but they're not going to contribute to the potential fault current of the system. So a quick answer to get that one out of the way.
Let's see. So should we use arc flash clothing when servicing 125 volt DC batteries? So I believe the answer that we're going to provide here, it's ultimately, it's kind of at your discretion. So the decision to use arc flash clothing when servicing 125 volt DC batteries should be based on a thorough risk assessment and compliance with relevant safety standards and regulations. So obviously making sure that when you are interacting with that level of voltage, that you are properly suited up in the PPE that is required or rated for that specific application and environment. Obviously, the last thing we want is for you to expose yourself to that inherent risk and create an arc incident. So doing that initial risks assessment and identifying the properly rated PPE, that would be the recommendation that we would make on that. Okay. I think there's a lot more to that as well. But yeah, I think that was kind of the quick, I see a question here about monitoring automotive batteries during the manufacturing process to alarm before thermal runaway. So it looks like a thermal runaway is an incident where one exothermal process triggers other processes. So, ultimately monitoring an automotive battery, that would be probably something within our GraceSense IoT family of products. I wouldn't say that would be like a normal use case, but in terms of like monitoring voltage or I guess level of voltage, that's something that we could possibly put together. I would suggest sending us a little bit of more resource or information on the actual application itself. We can take a look, see if we can't get something configured for you. More than likely, it would be something within our panel mount node. So I don't know what you're currently utilizing to monitor. If you are doing anything to currently monitor the battery during that manufacturing process, we could maybe look at including that into our larger GraceSense family of product and then tying it back into your SCADA or DCS system. So send us an email. We'd love to learn more and we can take a shot for you.
Yeah. As far as the GraceSense, we have an idea of where the products as we designed them, where they fit really well. But a lot of the really fun applications come out of customers realizing, hey, there might be a way for you to take this and solve a really big problem I have.
Yeah.
And one of yours was one of the most interesting to me because I never considered using the GraceSense vibration monitoring on a garage door. But it had such a big impact. So can you share that and just see how it's... So we're thinking of rotating assets, you're thinking pumps, wastewater facilities, all these, and then we get a distribution center that says my garage door needs to be monitored. And then you just realize all the things that happen if you unexpectedly shut down a garage door at a distribution center.
Yeah, so you think of a distribution center, right? There's a lot of docks with doors. Now, obviously, those doors are going to open and close utilizing a motor or some type of power there. So if a dock door, for instance, were to go out of order or not work, could potentially create a traffic jam, right?
Inside and outside.
Inside and out. Think about how many trucks are coming into a facility, getting loaded, unloaded. Ultimately, it's hundreds of trucks a day. So we're actually looking at monitoring the actual dock door itself and the associated motor, trying to identify, the vibration, maybe even potential temperature, just to see if there's any anomalous behavior and prevent a dock door from not opening or closing and getting those drivers loaded up and on their merry way. So ultimately it wasn't, I would say, a standard application, but it was a very interesting one that we're very excited to potentially pursue and hopefully roll out.
Absolutely. Yeah, it's been distribution centers are real key players for us right now.
Yeah.
So a lot of conversations in that area. So if you're interested in the impacts that we can have, the conversations we've been having, get in touch so we can go over the feedback we've received. You're probably not alone in your situation. If you feel like you're the only one dealing with a problem or encountering something, chances are some other people have vented about that. And whether it's to Chris or I, we have connections in this building. We can go around. We can find, you can add some resources to your toolkit if you're trying to resolve a problem. And that's
Absolutely
really what it's all about. Is we're happy to be that resource, happy to be that consultant for electrical safety. And that's the presence we have in the industry.
Well, we're coming right up here on our time.
So
really appreciate the time that you've given Nick and I, especially for Electrical Safety Month. Again, if there's any questions whatsoever, please reach out to myself or Nick. We can certainly work internally with our team to get you some answers. And we really appreciate it. Thank you so much for your time today.
Absolutely. Thanks, guys.